Hello, this is Dr. Christy Patton Lukes, and this is exam 3 for uh, Thermo 1, and this is our solution for that exam. In question 7, we're looking at N-heptane, and that data is given here. And we want to find the volume using the ideal gas law, and I give you an R value. Now, volume in this case, unless they specify total volume, means specific volume, and that's RT over P if I assume it's an ideal gas. And so this is just simply a matter of substituting in the values given. And I think almost everyone got this right, except for a few of you decided to do molar mass as N, right? You did the old PV total equals nRT, and you put this value in for N, and that was like nonsense. So people did very well on that. On part B, people did fairly well also. I think there were like 1 or 2 people who made arithmetic mistakes, but you're going to simply go through and divide by the critical value, which is given here. Make sure the units are the same, numerator and denominator, and you get 0.463. The units cancel, so this is a dimensionless quantity. For PR, we get 41 over 27.40, and so 1.50. I've specified 3 significant figures. And the reason for that was really so that I would force your hand on what to interpolate and not interpolate. So the pressure is 1.5, and TR is between 0.45 and 0.5. And so you needed to interpolate to get part C. Now part C, you need a Z0 value, which if you do the interpolation formula, my 2 nearest values are 0.45 and 0.5. And my 2 nearest values of the Z0 are 0.3077 and 0.3294. And so you get 0.3238. And similarly for Z1, you'll get negative 0.13724. And you didn't need to show your work on that, but you did need to interpolate. Z is Z0 plus omega Z1. And when you do that for omega equal to 0.35, you end up with a Z value of 0.275814. Okay. And I asked you to find the volume, the specific volume. So Z times VIG, Z is defined as V over VIG. And so therefore I end up with 0.1398 liters per mole. And then finally, to get the residual volume, you simply take V minus VIG, or you could have done the VIG times Z minus 1. Either way works. And you get negative 0.367 liters per mole. Now, there were several people that commented that they thought that negative seemed like maybe their answer was wrong. But in fact, if you look at these values of Z, I'm down in the liquid-like territory. And so in that case, I would expect that in a real gas, the volume would be smaller for my liquid than it is for an ideal gas. Remember, in an ideal gas, the molecules are not interacting with each other, and even in a real gas, frequently the volume of the real substance is smaller because those attractive properties between molecules. So anyway, this completes question 7.